Okay, so we're looking at rounding, and why is rounding important? Well, rounding is very important both in maths and in real life, and is a handy way of making complicated numbers easier to work with. So, for example, if I wanted to express the population of the world, instead of having to say 7,125,547,365, I could just say 7 billion. Now, even though that's not exact, it's an easier number to work with, an easier number to say, and just makes it a lot simpler to use. Rounding is also used in business. For example, instead of worrying about 97 people coming to a meeting, you might book a place for 100 people, because obviously it's still going to have enough capacity for all of those. So we're going to look at a way to round different things up. Well, the first thing to look at is what we're rounding to, and to do this we need an understanding of place value. So if I was asked to round 2.7456 to 2 decimal places, well, if I look at my place value, I've got units here, I've got 1 decimal place there, 2 decimal places, 3 decimal places, etc, etc. So I've been asked to round to 2 decimal places, so I'm concerned with this 4 here. Now, if I'm rounding, I need to know if I'm going up or down. To do this, I look at the number next to the 4, and that's a 5. Now, our rule is, if it's 5 or above, we do round, we go up. However, if it's 0 to 4, then we don't round. So a 5 is in the category which we would use to round up. So 2.7456, 2 decimal places is 2.75. That 4 just going up 1 because 5 had enough energy to put it up. Let's look at another example then. If we had 3.8964 and I was told to round that to 3 decimal places, well, this time I'm going to look at my 3rd decimal place column, which is this one. And I look again at the number next to it. Now 4 unfortunately does not have enough energy. Therefore, when I round, this one becomes 3.896. There you can see I have rounded to 3 decimal places. However, the 4 didn't have enough energy, so the 6 stayed the same. So now that we've looked at rounding to decimal places, or we've had a brief look, there's also another way I can be asked to round, and that's to significant figures. Now, if we take an example of 54.68, and I was told to round this to 2 significant figures, well, my first significant figure is the number which has a value, and in this case that would be the 5, so that would be 1 significant figure. Now, in the same way that as we go across, we go 1 decimal place, 2 decimal place, 3 decimal place, it's the same as significant figures. So the number next to the first significant figure will be the 2nd significant figure. Next to that will be the 3rd significant figure. And of course, next to that will be the 4th significant figure. So I was told to round this to 1 significant figure. So as with decimals, this is the one I'm concerning myself with, and I look at the number next to it, and if you remember our rule, 5 and above rounds up, 0 to 4 doesn't. Well, 4 doesn't round it up, so therefore my number is not 5, but 50. Because 4 is on the left side of the decimal point, it doesn't just disappear, it does lose its energy though, meaning that we're left with an answer of 50. Now, if I was asked to round 0.008469 and I was told to round that to 3 significant figures. Now we need to know, where is our first significant figure? Well, that's the first number which has a value other than 0. So in this case, my first significant figure is 8. Next to that, 4 would be my 2nd significant figure, 6 would be my 3rd significant figure, and 9 would be my 4th significant figure. I've been asked to round this to 3 significant figures, so I look at the 6, I look at the 9 next to it, which does have enough energy, meaning this rounds to 0.00847.